Moving along with equilibrium, we're going to further talk about what this actually means, the K value. So when you're doing these problems, you get an answer. Remember, it's unitless. There are no units for equilibrium, which is kind of nice. You don't have to worry about whatever happened to go into it. You can just ignore because it's based on a ratio of products to reactants. That's all it is. And this has a number. The larger that number is, the more products you have. The more reactants you have, the more it doesn't go to products. It doesn't run. So it's like, why are we doing this? What is the purpose of equilibrium? The purpose is to give you an idea how a reaction drives. Does it really produce a lot of products? Think combustion, it produces a lot of products. When you put an acid, a strong acid in solution, it goes all the way to products, hydrochloric. Some things just don't seem to go. They just kind of sit there on the reactant side. They don't react. That's what we're getting at. So K is a measure of direction. I had to pause there for a second. You could hear there, my dog was on a barking spree. So I had to go ahead and pause and close the curtains so she can't stare out the window and bark at everything that moves. All right, moving along. K is a measure of direction a reaction moves to at equilibrium. And this is my little shortcut for equilibrium. K, if it is very, very small, or excuse me, large, larger than 1, then products are favored. If K is very, very small, something much less than 1, then reactants are favored. Okay, let's continue this. If we reverse a K expression, so for example, 2NO2, which were products before, and 2O4, we find the inverse value of K. So before it was written the other way around, and we had a K value. If we reverse the reaction, just write it backwards, you get the inverse. So 1 over K, K, 1 minus, either one, would be fine. Another possibility we could come across, sometimes an equation is doubled, or any multiple you want to put on there, such as 2 and 2O4. Again, using that same example we started off in the beginning, and we'll say 4NO2. If we do that, therefore, for Kc, we would have NO2 raised to the 4th power, again, products of reactants, and 2O4 raised to the 2nd. So, where Kc was 0.212, or whatever value we happen to have for reaction initially, the new Kc would equal, I'm going to write it, I'll put it down here. 0.212 squared. Okay? One more set of examples to put on this. We can also use Hess's law. I'm sure you all remember that and are fond of it. And add reactions together. So for example, we have an initial equation. It has a K value. I have a second equation. Br2 plus Cl2 producing 2 BrCl. So again, we can add equations together. And if we do so, looking at stuff that we have here, some things cancel out. Ultimately, what we end up with for this reaction is this. Now, if I do the whole products over reactants, I would have Kc is equal to NO squared product BrCl squared, still a product, over NOBr squared and Cl2, but not squared, that's just 1. And as far as the values over here goes, because we've multiplied the stuff together here, we could actually have kept these separate and then put them together and canceled things out that were the same on top and bottom. But just to kind of shortcut this out, what we actually end up doing is multiplying these two values together. 0.014 times 7.2. And that'll give us a value of 0.10. Okay, to kind of sum up all the stuff that we did in all these steps here. Very short and sweet. I'll wait over here. Sum up. 1. If you reverse a reaction, whatever you did, it's the inverse of K. If you multiply the reaction by some coefficient value, whatever value you multiplied it by is what you are raising K to. If you double it, raise it to the second. Triple it, raise it to the third power. And the last, if you're using Hess's law, K1, reaction 1, times K2, reaction 2, is equal to the new value for K. So you multiply the K values by each other. All right, this is probably a good place to stop before we get into the next part of the discussion, which is a good one. You're going to want to come back and see how that goes.